Hey everybody, Mark McComb here, taking a closer look at the MPLAB Configurator graphical programming tool version 3.0. I've created a new MPLAB X project called Blinky, and I'm going to use the integrated programmer debugger on a Curiosity development board to program a PIC16F1619 with the Blinky application code. I'll launch the code configurator by clicking on the button at the top of the IDE. Let's look at the main areas of the code configurator. Over here on the left are the resource panes. At the top you'll see project resources, which indicates all of the microcontroller resources that are currently being used in this application. Highlighting the system module will display the current settings for this resource inside of the composer area, like the oscillator used for the system clock, or if I have the watchdog timer enabled. I can also configure and make changes like enable the low voltage programming, which I'll do now. This is a requirement when using the Curiosity board's integrated programmer debugger. The device resources pane down here lists all available resources specific to that microcontroller, including peripherals, data sheets, and even libraries. I'll double click a PWM and then a timer to add them to the project resources under the peripherals heading. Highlighting a peripheral allows me to configure its settings inside of the composer area, like what the duty cycle of the PWM will be, or which clock source and associated prescaler for the timer peripheral is used to set the PWM period. The easy setup view here provides a high-level overview of the microcontroller features and peripheral modules. If I don't understand a given configuration parameter, I can easily just go ahead and search for it in the datasheet. In this way, I don't need to do a deep dive into the documentation, and I can just focus on sections appropriate to my application. The Registers tab provides direct control over resource registers, and any changes will be reflected in the easy setup window here. The Notifications tab guides the user by suggesting actions that may be required or peripheral dependencies. As an example, this notification specifies that PWM3 is currently configured for timer 2. But if I select timer 4 here from the drop-down menu as the PWM3 timer source, this changes the notification to an information icon which explains that PWM3 actually uses timer 4 now. In the pin manager, I can select the package from the available packages for that device and view any pins that are currently in use. The table view here is where pins actually get assigned to specific signals for a module. The PWM3 output can actually use any of these pins here shown in blue with the unlocked icon. I'll go ahead and click pin 5 on the chip, changing it to a green lock symbol, which also gets updated in the package view. I can rename the pin and make additional peripheral specific pin configurations inside the pin module in project resources, which also changes the name in the package view. When ready, I can simply click the generate button to generate the C code based on these configurations. Yes, I'm going to save the configuration file, and the output window should confirm that I've successfully generated some code here. If I click on the Projects tab, I can view header and source files that have been generated along with a main.c source file. Scrolling through the main.c file, you'll notice that there's a specific area here created to add application code. A variety of streamlined Microchip verified functions are generated in each peripheral source and header file. These functions allow the microcontroller to dynamically change peripheral characteristics in response to system changes. Functions are defined inside of the associated header file. As an example, if I open the pwm3.h file and scroll down, I can see a function that actually allows me to change the duty cycle of the PWM output. Function descriptions, parameters, and even example code can be found just here above any function declaration. Download the project by clicking the Make and Program Device button, and the IDE will connect to the Curiosity board and program the PIC16F1619. Once the download is completed, you can see the PWM signal connected to the pin we assigned at configuration is actually driving this LED here high and low at a period defined by timer 4. For more information on the MPLAB X code configurator, including the user's guide, or to download example projects, please visit the MPLAB code configurator homepage at www.microchip.com/MCC. I'm Mark McComb. Thanks for watching.